We're just going to cover what is known as functional programming. This is just barely going to scratch the surface. A lot of what I'm going to explain to you are going to be sort of like core concepts behind them. Do not feel like you have to walk away with this mastery understanding of functional programming. Just after this lecture, you should have an idea of what this is and how it's sort of different than what you already know. Cool? So, is this a little, oh no. Is that a little bit better? Cool. So, functional programming. We're going to define what a pure function is, and naturally the opposite, like an impure function. Something about composition over inheritance. So inheritance is what you know currently and how you program your applications, because object-oriented relies heavily on inheritance, whereas functional will be a little bit more about something called composition. We're going to talk about that here in a little bit. So we're going to identify why functions are first-class citizens, because essentially they're just objects. They're treated like any other variable, and that's almost the exact definition. We'll read that here in a little bit. You can assign functions to variables, pass functions as arguments to another function, which is known as what? A callback, right? This function takes in another function. That function is taking in is the callback function. We're going to be able to understand that a function can return another function and why that's useful. And then we'll write both keyword function and arrow function. And I'm going to explain the differences in this lecture. There's so much more that it does outside this lecture, and we're going to talk about that tomorrow in this keyword. Right? This keyword being literally the keyword this. I'm going to try my best to, this tomorrow, avoid saying this a lot unless I'm talking about the keyword this. All right? That's going to be a doozy. I like usually, yeah. That is a very good question. Yeah. They were like, is there a great word like self? No. Pass. We're talking about this. I can't tell you why, but what I can tell you is self does not work in all of the contexts that this keyword does. And so it couldn't be self like it is in Ruby, and we'll learn more about that tomorrow. All right, so JavaScript. I've said this a few times already. I'm going to try my best to demystify it today. JavaScript is a multi-paradigm programming language. What that means is that it can be functional programming. It can be written in the functional programming paradigm or style, or the object-oriented programming paradigm or style, however you want to kind of think about it. The nice thing is that it can actually do both. It could be a Frankenstein's monster of some functional programming and some object-oriented programming, all in the same application. Okay. The main difference between functional programming and object-oriented is that object-oriented programming, you're always thinking about exactly what object-oriented sounds like. What are the objects? What kind of data do they share? And how can I sort of relate them to each other, right? So let's just say you have a animal class, and that has a subclass. And that subclass is dog. So dog inherits from animal. And you're thinking about their shared state. Both of them what? Both of them breathe. And both of them walk. And so you're thinking about what you're about to build. You want to build some sort of dog class. And you're thinking about what am I going to put in this initialize method? That's object-oriented. There's a lot of shared state. Are there any questions so far as to what you know? Cool. The second you start to see some sort of initialize and the class keyword, that's when you're thinking object-oriented. And then in Ruby, what did you write a lot of? Almost exclusively. Your own classes. So you can create dog.new with a dog name and age, right? maybe like a belongs to owner, all this shared state. So far, so good? Cool. Functional programming, however, is more concerned about just the behavior of the code. I don't necessarily want to couple all of the state that's in there. This is going to be really confusing at first, and the difference is very minute. Until you finally understand it, attached on the bottom of this README, I'm going to add like a couple of Medium articles that if you read through, the more you see and the more you read through it, the more it will make sense. But the functional programming is not concerned about the object and its shared data, but more about what is it that it does. So it's not about like the dog inherits from animal. It's just that, can this dog walk? What is the dog walk function? And so you have something like map, reduce, filter, and for each. What you're really saying is, for each of the things in the array, do this thing. This has nothing to do with the shared state of a particular object. It's just doing something. I'm going to map through this array. I have this array of instructors, right? And I'm just going to map through them, right? I can easily do something like, let's see, the instructors array, right? I can run .map, cool. And this takes a callback, right? Do you want me to put it in here, or would you like me to extract it out? Put in? Cool, I'll put some spaces so you can see it. First, I'm going to write this function keyword. Cool. And what does this function receive? Right, some sort of instructor, right? So here I'm just going to say a name. And then what it's going to do is what? What do you want this thing to do? Just maybe just name like 2 uppercase, something like that. Cool. And this is going to be a const. It's just going to be capped instructors. Cool. And then I can, I spell something? Oh, break yourself. It's more like capitalized. This class is very intense. Cool. That's so weird. I get undefined. Oh man, what did I do? I did not return. What else? That's it? Don't overthink it, right? One thing at a time. Cool. Great. Interesting. I see I have this. So what is capped instructors? It's these capitalized names. What is instructors right now? Is it the capitalized? Are these all capitalized afterwards? If I were to console log the instructors, what should I see? Right, I didn't mutate that data. The original data is still there. What can you say in regards to this array and what it's doing? Would you say that there's some sort of shared state in regards to this and any other object that you know about? Currently, just in this sort of example. Right, it sounds sort of nebulous, but you should be thinking in your head like, I don't know what you're talking about because I don't see or understand this shared state between this array of capped instructors and regular instructors. It's just, I have this array of instructors. I'm going to do something to it, and now I have a new array of instructors. There's no shared data or state between these two objects. Does that make sense? That's sort of the idea between functional. Functional is concerned more about what it does. It's doing something, possibly mutating or not mutating. And then object-oriented is about this shared data, this initialize method, right? Everything has an age. Every time we make a new object, they all have, while different, they all have a name. They all have 2 legs. There's like shared data. Cool? A lot of this is going to be relevant in regards to how you manipulate the DOM, specifically as you get into React. So this is just important concepts to kind of like try your best to wrap your head around, but don't focus so much on being like, great, I've mastered it, I understand it. Just know that there are two different paradigms and what they focus on. Cool? Great. Functions are first-class objects. What does this mean? Functions in the language are treated like any other variable. So, we've seen this before, right? We have a function, right? And we have a fun function. And it really says, I'm super fun, kind of, right? I can also just set it to a variable, right? Const, right? Mega fun function equals to a function. And this is just going to say mega fun. Do you see a difference between these two? I talked about this on day one, and that is in regards to this keyword function. Does this hoist? Keyword function hoist. Who's confident that it's yes? Who's not confident? And that's okay, because guess what you could do? Does keyword function hoist? And you will find very quickly, yes. But what's more important than that is, do you know what hoisting is? That's more important. So there is a difference between these two. The way JavaScript reads your code is it will run through, remember, top to bottom, left to right, 2 times. The first time it goes through, it will see, oh, keyword function, and store this in memory. It will see const megafun function and an assignment operator, and then do what? It will be like, great, I have this in memory, awesome, super, and then keep going. It will not assign this a value. Specifically for const, though, what will happen? It will do nothing, right? If this was var, what will this be on that first read-through? It would be undefined. Remember, if this was var, oops, not car. If this was var, when JavaScript reads through your code, it will see var, some name, see this equal, and go, great. I will assign it to be undefined on my first pass-through. The second pass-through, it will actually assign the value. So there's going to be a difference here. Const to? Nothing. Because const and let, do they hoist? Do they hoist? Sorry. Const and let do not hoist. So on that first read-through, it'll see const, and it'll be like, okay, great. I will execute this at runtime. Right, in that second sort of run-through. Cool? Versus this keyword function. So I kind of alluded to this on day one. If I had Ruby, right? See how I have this like variable here, and it's a function? In Ruby, how do I define sort of actions in Ruby? Like methods, right? So I have def, right? And then I have a fun method. And all it does is it puts, right? Ruby is so great. You miss Ruby? Yeah. Cool. Can I do something like Ruby method equals to this, oops, whoa, this right here. And then later on, I can have another method, def, right, second method, that takes an argument. And then can I put, right, like some method in here? No, because then in order to invoke it, I'd have to put some method passing in Ruby method. Can I pass in sort of a definition of a method into Ruby? No, That's crazy. I can't store this method into a variable, have a method take a callback, and then execute that method with a callback. So, is Ruby considered a programming language with first-class objects? No. Is this definition a little bit more clear to you in an exact, explicit example? So if somebody were to say to you that JavaScript has first-class functions, you should not at this point be like, I've never heard of that and I don't know what that means. Whether you can regurgitate that from memory is a different story. I can because I have to lecture to you, and I do this every 3 weeks. But you should understand what that means. Cool? Is that fair? Also, a lot of the things that I tell you and explain to you, the READMEs are very comprehensive. They will be asked in JavaScript interviews. One of the first things you will always get asked in an interview is, hey, how you doing? My name is Greg. Great, awesome. Greg, nice to meet you. It says here that you program in JavaScript and that you know JavaScript. Great. Talk to me about a closure. What is that? Great. So JavaScript, as you know, has first-class functions. Can you write an example of a first-class function? Tell me what that means. You don't need the MDN definition, but you should say, great, yeah, JavaScript has first-class functions. All that means is that I can assign a function to a variable and then pass that variable around, either as a callback or reference it as a variable itself. Cool? Great. So again here, I have a const, a variable that is a reference to a function. And then I say, I have another function, is this callback true? All it takes a callback function. So if, and then I invoke the callback inside. If this is true, return true, else return false. Right? This function doesn't really do anything. It's just an example that you can pass in a reference and then invoke it. The difference being the bananas. Cool? Right. Functions can also return other functions. So I have an outer function here. I'm setting a variable inside this function. And then I return another function. Cool. Let's take a look at this. Great. Without sort of looking at this. Great. Let's just focus on this for like 2 seconds, right? I have an outer function. What would I see if I just referenced outer function here? What should I see? If I were to just reference it, I should see this whole function definition. And there it is. So far, so good. If I were to invoke it, what should I get back? If I were to put the bananas on outer function, what should I get back? The return value, right? Which is going to be an inner function. So if I put outer function with bananas, what should I see returned? Should I see a log? No. I should see a definition of this function here. So let's take a look. And there it is. With the bananas. Yeah. Very good. Do I have access to this inner, okay. Do I have access to this inner variable? What has access to the inner variable? The inner function because of the lexical environment and the scope chain, right? This function has access to this inner var. But because this whole thing is enclosed, creating a closure, can I access inner var on the global? I can't, because it is enclosed inside this function. And because this inner function references this outside variable, this free variable, it is being captured. So this closure scope has access to the inner variable. Global does not. This would be the whole thing is considered the closure. So tricky, tricky, tricky. In the closure, people think that it's always the function that returns, but it's really everything encapsulated between the function. This whole thing is the closure. Cool? This is useful because in Ruby, how did we create private variables? Do you remember strong params? What did I put right before strong params? Private. So inside my class, I just put private, and then anything after that is considered private, right? I do not have access to it outside the class. Do I have access to this inner variable? Oh my God. Do I have access to this inner variable outside of the outer function? Can I call this inner variable outside this outer function? No. So this would be considered, for all intents and purposes, a private variable. Yeah?
So when you say closure, it's essentially everything that is involved in the function.
Correct. If, however, I had, let me just refresh this, yeah? If I had, however, another const, right? And this is like worthless equals to sad face. I don't feel like using emoji. Is this worthless const ever referenced anywhere else? No. This right here is actually not considered a part of the closure.
So it's only considered part of the closure if it's actually referenced.
If it is ever used, if it is ever captured.
So
Cool.
it's literally it's doing nothing, so it's not part of the closure. So you would say it's only part of the closure if we're actually invoking it.
Or if it's ever being utilized, yeah. This sort of just goes away and it's never utilized. Is there? It's a free variable that is not captured. There's no special word for it, so to speak.
You never really see that though.
Right. And in a code review, you will never see it because as a senior developer, as like an architect reviewing your code, I would ask you like, hey, on line 2, you have this literally worthless const. Are you planning on using that later? Oh, no, my bad. I was just debugging something. Great. And then this will go into production. So there's no real word for it because, you know, you shouldn't really see it. Cool? Any questions so far?
What if you do outer function and the 2 bananas? Should you do like a...
So outer function, 1 banana is a reference to a function. This function can be invoked. Yeah, double bananas. Yeah.
What would happen if in the same layer of the function you also had another function?
That would be part of the closure. If this inner function, what you're saying is like somewhere here, right?
Yeah.
On this like sort of empty line, if I had another function.
Yeah.
If this function takes that inner function as a callback or is being utilized somehow, part of the closure. If I just define a function here for no reason and I never use it, I'd be like, what is that doing?
But could you call it, like, for instance, the second set of bananas in outer function? If that could possibly refer to...
Never. I can never access anything inside the closure from the outside.
That's why you need
So we just deal with the 2 sets of bananas.
That is accessing the return value. Remember, when I first invoke it, it gives me this function back, which I can invoke, which is why this is giving me this function, which can be invoked.
So by taking away that return before the inner function, you could get the result with the 2 sets of bananas.
So if you just ran the code with literally without a return for a function.
Yeah, I would get undefined. Actually, it would say that I can't invoke undefined. It would throw me an error. It says that this is not a function. So what you're saying is this, right? Without the return, what the, oh, I can't have an anonymous function in there. It don't like that. So I can say not anonymous, all right? And what you're saying is what happens when I give the outer function? What happens when I invoke it? Undefined. If I want to invoke undefined, it is going to tell me that the return value here is not a function, so I cannot invoke undefined. That would literally be like if I was like undefined and then was like, great, let me try to invoke that. Huh?
Probably not.
Yeah, terrible. Trash. Cool? Great, let's continue. Actually, I should get rid of this because I don't know why it didn't break on me. JavaScript should have been like, what are you doing? That looked like a Ruby, huh? Oh yeah, actually, yeah, it did. It threw me like a huge error. Yeah. Great. Ruby, however, right, and this is not a lesson on Ruby, I just want to demonstrate, has something called procs. Procs essentially is just a block of code. So you can do proc.new, passing it in a block. Block just being something that's defined between two curly boys. I can save that. And on this each method, I can pass in this block. This ampersand turns this blockified code into executable. It's the exact same thing as if I were to put this. Because remember, here and here is the same. Dot each, I'm passing it in this block. This is exactly the same. This is the closest that Ruby can do to callbacks. However, this is just a block of code. It is not a full method definition, and it does not work the same as a callback. Cool? Like notice this block and how it looks versus like a full function or method. Cool? That's just the parallels I'm trying to draw. Do not stress or focus on procs. Okay? If you forget that entirely, I would be okay with it. Let's talk about this arrow function and its juiciness. Right? Great. What I can do is I can have a keyword function, and I can put not arrow, boom, 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 boom. Oops. Let's just do it here so you can see it side by side. I can have a function, not arrow, and this is just going to log not arrow function. Cool? So far so good. I can also, how would I write this arrow? Bloop bloop. And that's going to log. This is the arrow. Cool. I didn't invoke this, right? And I didn't invoke this, so I shouldn't see it. How would I invoke it? How would I invoke not arrow? With bananas, right? If I refresh, I'll see it. Not the arrow function in this sweet purple. How do I access this? I can't. This is just a function definition, and it's anonymous. Const arrow function equals to an arrow function. Yes. Arrow functions cannot exist. Well, they can exist on their own, but it's kind of like writing code that you never use, right? I can easily do var x equals to 7 and then never ever reference it. Or I can just say, for whatever reason, if I wanted to, 7. This is perfectly valid code. What it does, I have no idea. How will you ever reference it? Me no, right? Cool. Not exactly, and there's an exception to that, and I'll explain to you next. But I just want to show you that in order for the arrow function to not be anonymous, you have to assign it to a variable. Cool? So naturally, then, I can just do arrow function and invoke it. Cool? So I see not arrow, and then this is the arrow function. Nothing crazy, right? Here are the weird things about the arrow function. If I wanted to put something in the not arrow, if I wanted to put arguments, what would I do? Right here, right? arg1. And then I can, if I wanted to, let's do this. All right. I don't know. What's a fun name or variable? I got you, fam. I got you, fam. Cool. And then I can simply, in this argument, say, you know who I'm talking about. The great, the master. Mike Cheng's so powerful, right? I can do the same thing here, right? This is just some argument. Argument 1. And then naturally I have to like actually put it in here though. Cool. Plug up, plug up. All right. What do you want in here? Oh man. Oh Mike. Cool. No big deal. Do you see how this works so far? Cool. Arrow functions are magical in the way that if this is all on one line, for example. Oh man. Let's do that. You see how this is all on one line? It's one liner. Cool? Cool? So far so good. No change. If it is on one line, it will have an implicit return. I do not need the curly brackets. Cool? Only, huh? Yeah. Only if it is one line. Not 2 or 3 or -1. It's one line. Yes. Now, if and only if you have one argument, get rid of the bananas. Let me just change this. As many cats and no bananas. Oops, I didn't save it. You're right. I have to sing that song every time. B-A-N-A-N-A-S. Cool. Thank you for that. That's embarrassing. Cool. I do not need the parentheses if there's one argument. This does not work for no arguments. That would be crazy. How would you even know that's a function, right? It also does not work if there are 2 arguments. It will not work. Cool? 1 and only 1. So, real quick. 1 argument, no need for the parentheses. And 1 line, no need for explicit return. The keyword return. Are there any questions on the arrow function and the magic that it does? Do you remember your code should have seen something like this? Dot then, right? And then you had a function, right, that took in some data. And then you did something to that data. I need to fix that shortcut. It's not serving me very well. Cool? You should have also seen something fairly similar if I did a dot then, right? Instead of console logging, you've seen this, right? Parsed equals to data.json, right? Let's refactor this slowly. Get rid of the function and add the arrow. So far, so good. Now, let's make that bad boy one line, which means I don't need the curly boys. But there's one argument. And then data is cool, but so is response. So, you seen this? That's how it got there. Cool. This also will not work. Why? Yes, there's no return. If you want to get crazy, you can just... Now you're really cooking with butter. Cool. In this case, absolutely not. This is more sleek, and it's just as readable. To be honest, this is in my opinion the preferred way. But if you write this and someone says it's trash, they have no idea what they're talking about. They're just, I don't know. They're being douchey. Yeah. Rookies believe that the less lines of code you use, the better. Trust me when I tell you, 100% not the case. 100% not the case. I'd rather 6, 7, 8 more lines where the code is significantly more readable than if you're trying to like nest ternary operators. So you can have this one sick line of code. Oh, it's sick, all right. Needs a doctor. Cool. Any questions so far on the arrow function? The implicit return and invoking it without, defining it without parentheses if there's one argument. Great. Right? So here, again, the README is like really thorough. Cool. If, however, you go more than one line, do you need the return? Yes, cool. So this is just an example. I mentioned that I was going to get to something where there's an exception to sort of having to invoke it. And that is something called an IFI, an immediately invoked function expression. An IFI, immediately invoked function expression. Cool. So let's talk about this. Boop, 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 boop. We can just have, right, a const, right, my IFI. And it's just going to equal to a function. Bloop. Cool. And all it's going to do is console log, right, my IFI. Oops, sorry. Are there any questions as to what this function does so far? Pretty similar to what you already know. Actually, exactly to what you know. I haven't done anything to it yet. If you're confused here, just see me after. We'll talk. But are there any questions on 37, 38, 39? If I wanted, right, what does this return actually? Let's return something. Return, I don't know, hot dog. Unless there's like a cooler name you guys want. Hot dog work. I'm hungry. Oh, D-A, hot dog? Powerful. Cool. Great. Let's take a look at what this is, right? I can actually do this, my IFI, and invoke it, right? Couldn't I invoke it immediately? On the actual definition, I go ahead and invoke it. This whole thing, right, I want to make sure the automatic semicolon insertion is good and that JavaScript reads through this whole thing all at once with the evaluation. I'm going to wrap this whole thing in parentheses. Notice that I wrap the function definition here, and then I invoke it. If I attempt to wrap this should not work. Because it thinks this whole thing is a function definition, which it is not. So I wrap the whole function definition in, and then I invoke it. Cool? And so if I were to console log my iffy, what should I get? If I were to log, oh man, I'm gonna fix this, I'm sorry, this is my bad. What should this be? It should be hot dog powerful. Man, that didn't even sound right. It's embarrassing. Let's fix that. Cool. Right? So what it's saying is, I'm not actually storing the function in here. I cannot and should not attempt to invoke it. Because my iffy is not actually a function. It is the return value of this function that is invoked. My iffy, I'm saving, remember, this is a space in memory. This variable is going to be the return value of this function because it's being invoked. What does this return, right? In the same way that if I did var, right, like 7 equals to 3 plus 4. I'm not saying that 7 is 3. I'm not saying it's 3 and 4. I'm actually saying because this gets evaluated. This is exactly the same. All right? So I'm storing this as the return value of this function. Are there any questions on the?
Kind of like you're doing the two bananas, because one is like inside the first banana, and then you're getting the generic part by calling it.
Right. If I, however, instead of this, I return another function, then my iffy would be a reference to this function. So far, so good. Because this is being invoked, and it gives me a return value, and this return value is a function. So my iffy will actually be this function. Cool, I'm just going to leave this here, and this is wrong, because I can't invoke it. Cool, so let's take a look. Actually, this is already defined. What is, oh, sorry, I had these trash thens. So what is my iffy? It's just the return value of this. Yeah, right? So I can have, if I wanted to, a const, right? Oh man, is there one in here?
Yeah.
Rubbish, as they like to say. Yeah. Look at this, rubbish. Rubbish. Cool. All right? It's just this, the return value. Cool? If I had a function in here that used trash, what do you think would happen? This would be the return value. This would just be a function. Cool? We talked about scopes and closures already, so I'm not going to dive too much into that. Any questions on iffies? Great. This is where it's going to get dicey again. I tried my best to explain functional programming. Sometimes abbreviated as FP, and you've already seen object-oriented as what? OO, right? So like OO JavaScript. So if I say OO.js, you know I'm talking about object-oriented JavaScript. If I say that Ruby is a OO programming language, it should start to make sense. So we're talking about pure functions. I'm going to define it right here. A pure function is a function that does not mutate the data. Doesn't have destructive properties. And so when I ran map earlier and I capped those instructors, man, that sounds terrible. I capitalized the instructors, thank you. And I looked at instructors array again. Was it changed? No, map returns a new array. So just like I did for you in the for each, I went ahead and wrote two different types of map, right? This should look very familiar to you, just like you did in Ruby, and that is you have a map function or map method. It takes in an array and it takes in a callback. So far, so good, right? Just 2 arguments, the actual array I'm going to map through and what I'm going to do with that array. I have an empty array here. I'm going to do a for loop. Start at 0, index or 0. I'm going to iterate through plus plus for the entire length of the array. I'm going to say this mapped element is going to be the callback with 0, 1, 2, every item in the array. This callback can just do anything I want, like say, take in an argument and run 2 uppercase on it. Then I'm going to push the mapped element. So we can think of, right, let's say this callback, right? Don't call it this because it's very confusing, but callback function. So I'm just put like let, right, or const, whatever, equals to, right, a function. And all it does is, remember, I'm receiving an argument here, right? So I'm receiving some sort of element in my callback, right? When I invoke it, I receive an argument, yes? So I have an element here, and all it's doing is I'm going to return the element to uppercase. So if I were to call my map and say my map on an array like 1, 2, 3, I'm sorry, that's not going to work. Right, your boyo, and chef boy RD, passing in this callback function. Do you see how this is working now? And all it does is, one more time, my map, it takes in an array. This is an array, a callback function. So I set an empty array. I loop through everything in the array. The callback is actually this function. God bless you. This callback takes in an element. And all it's doing is returning it uppercase. So your boyo gets pulled in right here. And then your boyo to uppercase is returned. And then that's the mapped element. I simply push capitalize Yaboyo into this empty array. Then I do the exact same thing for chef, it's your boy RD. And now mapped array has 2 elements that are in fact ran through this callback, which are now uppercased. So when I return my mapped array, it is both the elements uppercased. Does this help a little bit with the callbacks as well? All right, I just need to reinforce this over and over. Again, it's just practice. You saw this before, you're kind of shaky, you saw it again, less shaky, you saw it again, kind of shaky again, you see it again, maybe a little bit less shaky, right? Every time you just need to walk through it slowly. It takes time, but if you ask questions, it should help, right? I've noticed that callbacks are tricky for this class, so I want to walk through it, right? Now, this is an empty array contained inside this function. And so, do I have access to mapped array outside this, my map? No. The lexical environment says that it's only available inside here. This mapped array, did I change the original array that went in? No, I did not. So you could say that the mutations are contained within the function, and there are no observable side effects. I will define everything that's a side effect here in a little bit. Just understand that I did not mutate the original data. So map, in fact, is a pure function. The data it takes in and the data it spits out will be exactly the same every single time, and it does not mutate the original array. However, an impure map will set the original array. Do you remember this? I could take the index of it and reset it with callback data. Return the original array that was then changed. If I look at array here after I run impure map, what should I see? The mutated data. So this is impure. Questions on pure and impure functions?
When you do like an actual map in JavaScript, like it's impure.
When I do an actual map in JavaScript is pure function.
What's that?
It returns new array. Are you cool with that? You want me to show you, or
What's that?
you want me to show you, or are you cool with that?
Cool.
Yeah. All right. Yeah.
So the only, I mean, the main difference is that you're setting between impure map and my map, you're setting a random.
Yeah. I'm actually just creating a new variable. I'm doing the dirty I need to, and then I'm returning this new variable. I never touch the original array and transform the original array's data, and then save it back to the original array. Cool. So, functional programming, pure functions, right? Avoiding shared state and mutated data, and avoiding side effects. Functional programming is declarative rather than imperative, where the application state flows through pure functions. Contrast to object-oriented programming, where application state is usually shared and co-located with methods in objects. I've provided this link, Mastering the JavaScript Interview. What is functional programming? Please, when you have some time, this is amazing read. It's an amazing read. Great. So, I use words like imperative and declarative, but what do they mean? Very similar to what I talked about earlier. Imperative has more to do with how to do the things. Declarative has more to do with what the program does. I read an article recently that I'm going to quote from. It's very good. Remember, declarative is what, imperative is how. So declarative is what this thing does. Imagine your boss comes to you and says, I need you to paint a mountain. Just go ahead and paint a landscape, get it done. That is declarative. It's just telling you what to do. Now, imperative is how to do things. The difference would be if I said, watch this Bob Ross video on how to draw this mountain. First, take this easel. You need to mix this color gray, this color gray, this color gray in these ratios. Stir them up real good and just make happy little clouds, just like this. Blot it on the top, holding the brush at this angle and doing this until the mountain is done. So imperative is how, declarative is what. Make the landscape versus Bob Ross teaching you how to make the landscape. How this translates in code will make so much more sense when you get to React. But that's just the idea between declarative and imperative. So far, so good. Great. Again, map is going to be declarative because map, there's no instructions on map. Map is just make this transformation, call to uppercase, return that value. That's it. A pure function has to have a return value. So console log, pure or impure? What does console log return? It returns undefined, right? Which is, in this case, we'll consider that nothing. Like where your head's at, though. Console log is not a pure function. A pure function will have no side effects, and I will now go into what those are. If I have the same input, we'll always return the same output. So far, so good? Here are the list of side effects. When you modify any external variable or object property, so when I called map, right, the original array does not change. when I call impure map and I actually change the original array, I am modifying an external variable to my function. I gave it an array, and when it came out, the original array changed. That was external to the function, and it changed it. So we talked about let and const being block scoped, and we talked about var not being block scoped. If you remember certain examples I gave, var has interesting access to your variables, and therefore can modify external variables. So var, pure or not pure? So do you see where the evolution came straying away from var? Not to say that it's completely not useful, but the idea behind why let and const was born. Cool. A side effect is any observable outside the function. Anything that happens outside the function. So when you console log, you're printing to the screen. That is something that happens outside the function. Is impure. When you write to the screen, again, a console log. When you manipulate the DOM, does that change something outside the function? Yes. Writing to a file, when you write to a network, fetch requests, pure or impure? Not pure, correct, because you're going to send a fetch request, in which case you will post or patch data. That will write to a database or a network request, trigger external processes. Side effects are mostly avoided in functional programming, which makes the effects of programming much easier to understand and therefore much easier to test. So I will give you an example here in a little bit, but any questions are sort of like what side effects are? Just have like a rough idea. Cool. Note that if your entire application is exclusively pure functions, your app will do nothing. Cool? There has to be some sort of impure functions. The goal is to separate them. You want to have as many pure functions as possible, chain those together, and then call one impure function, and that does the bulk of your app work. And that's how it works. And so that when you test, you know that all your pure functions are good to go. So when you need to debug, you only should be debugging the impure functions. Does that make sense? Great. Cool. Great. Boom, boom, boom. Again, this is just the capitalized example. Do. Yeah. That's fine. Okay. Remember, object-oriented, shared state. Functional programming does not. Shared state is any variable object or memory space that exists in a shared scope, or as a property of an object being passed between scopes. This is just when you have an instance variable, class person. Accessor says that it's both readable and writable. Anytime you make a new instance of person, you can read or write to that person's specific instance their name. Cool? Great. In essence, this means that we should rely on immutable data structures, because this class person, and I run, Billy equals person.new, passing in a string Billy. If I do Billy.name and reassign it, that is shared state. Every single time I call upon that instance, the name will now be the new name everywhere in my application. Does that make sense? That is the state of Billy. So, really quick. Actually, I should keep that. This is not going to run because this is Ruby. But then if I were to do Billy equals to person.new, passing in Billy boy, and then I were to say Billy.name equals to not Billy boy, and then anywhere I reference Billy in my entire application, did this mutate the data? Yes. So object-oriented, pure or impure? Okay, do you see how everywhere I call Billy, in my show page, in my index, in my custom route, Billy will now be different. Shared state. Is this starting to like make a little bit more sense? You don't have to have a mastery, just a little bit more sense. Cool. Sorry, that'll break my JavaScript. Our JavaScript. Very good. Yes, this is shared state. As I change this, you will get a newer, cooler README. Right. So, in order to do anything in JavaScript, we should do something called composition. And that will be when you have a function call other functions to combine them to do some sort of functionality. These examples are okay. Let's do this instead. I like this one. Do you guys know what a URL slug is? A URL slug. So, if you were to write something like Pizza Hut, right? Notice how here it says pizza plus hut. A URL slug is simply just something that I can transform a string into another string that I can then utilize like in my URL. Kind of really about it. I'm just like formatting a string a particular way so that I can use it for the browser, right? I did not put pizza plus hut in the search bar. What it did was it simply, right, took what I did. Anytime it found a space, it added a plus. So it slugified my string into something else. So far, so good? Great. Now let's do that functionality. I want to change Pizza Hut like this, like the obnoxious person that I am. I type in SpongeBob memes, right? And I want to change it into pizza underscore hut. What I should do is first lowercase everything. And then I can replace the empty space with an underscore. Cool? So that means that I can have a variable, which is a function, that takes the lowercase string. Is this invoked or not invoked? It is invoked here. So if I call URL slug with Pizza Hut, lowercase string gets invoked with Pizza Hut, and then it passes that new lowercase version into sub underscore, and that will give me the new data that I want, the URL slug that I'm looking for. Are there any questions to this? This is essentially function composition. You'll be very familiar with this because you probably did a lot of this in Ruby, and it's called method chaining, right? Where you just added on methods. Every time it did something, you added on another method and you chain them, right? Cool? No. But again, this is pretty readable. If I put another function around this, it starts to bleed into that unreadable category, right? If I look at this, without even explaining this code, I could simply see, all right, this, by the name itself, all right, this lowercase it. This, I don't know, I guess replaces spaces with underscores. Cool. Great. So first I'm going to lowercase it, then I'm going to add an underscore. Okay, cool, got it. When you add one more, you're like, wait, you're going to lowercase it, then add an underscore, and then do something else, and then do something else. It becomes unreadable. But you can do it as many times as you want. All right, it'll run. Last thing I want to talk about, all right, is this right here. You will have it in a discussion question at some point, but I can have a robot factory. It's just an arrow function. I can have a variable. Total robots created. Started at 1. Remember, this mutation is contained within the closure scope. So I do not have access to total robots created outside of Robot Factory. Check. I'm going to return a function that takes in name, blinking lights, in the microprocessor. And this function returns this, right? Sort of look familiar to you? Kind of like a, almost like an initialize. Almost, right? This almost looks like initialize. And remember, I wrap this whole thing inside parentheses, and then I invoke it. So this is a iffy. What I'm about to say is I can have T2000, right? Call my robot factory, and I invoke it. When I invoke robot factory, what does it return me? Maybe this will be better. Maybe this will be better. Huh? Remember, this whole thing is being immediately invoked. So robot factory itself should be a function. This whole thing is invoked, and if the whole thing is invoked, it returns me this function. So when I say robot factory, what do I see? This function. Therefore, if I invoke robot factory, I'm invoking this function. Passing in name, blinking lights, super false, microprocessor, uber dangerous, and then this function returns me this right here. So if I were to invoke it, what I should see is T2000 will give me ID of, actually 1. Name terminator, blinking lights false, microprocessor, super fast. This right here gives me access to a closure variable, which I can then access. Yeah.
So you could achieve the same thing if you remove return on line 78 and then put bananas at the end of line 88.
Before I answer that question, are there questions on what I just explained? Great. So you want me to do what now?
Remove return on 78 and add bananas at the end of line 88.
Add bananas.
At the end of line 88. No, at 88.
Oh, 88?
Yeah.
Like this?
Yeah. That's the same thing.
Would you have to put the bananas before?
No, if you remove the bananas from 86 and put them on 88, it would do the same thing.
Let's take a look, actually. Cool. Right? Oops. Oh no, I'm in JavaScript hell. On line 3. What's wrong with this function?
We took away the return on 7.
Yeah, but alright, let's just call robot factory here. Oh, sorry, this one. Oh, line 70? Where's that? Oh, because I did this. Cool. Right. So what is robot factory? Cool. That totally runs. I don't know what I'm saying. Let's. Okay. Cool. Yeah, that runs. Interesting. So you want me to just remove this return, right? Oh my God, I'm so stupid. When I do this, right, this function cannot be. Yeah, sorry. Yeah. Cool. It's nice to know exactly what line is the problem, because then you can like analyze it. I said that to a group earlier. So I have robot factory. is undefined. And you want me to invoke it, right? Look at the errors real quick. Robot factory is undefined. You want me to invoke undefined? It will never run. Because this iffy is immediately invoked. If it's immediately invoked, the first thing it will look for is the return value. And if there's no return value, it will return undefined. Yeah. So when you were asking me, I was like, I don't think that'll work, but let's double check. But cool. Yeah, for sure. Are there any questions on this iffy, this private variable?
Can you return an immediately invoked function?
Can you return?
So inside of an immediately invoked function, can you have a number at the beginning?
That sounds like something you can definitely test out. But let me ask you, before you get to it, what do you think will happen?
I feel like it'd be able to do it.
If it's valid JavaScript, it'll run. Why you would do that? I have no idea. But yeah, if it's valid JavaScript, it should run. Cool. Are there any questions on functional programming and how it differs from object-oriented? Great. If I were to ask you for one attribute of functional programming and one attribute for object-oriented, anyone want to help me out? What is one attribute of functional programming? Pure functions. Attribute of object-oriented. Shared state. Perfect. You guys are pros. All right. Thanks so much for your time today.